Para terminar este bloque, tenemos la presentación de Benecke de la empresa AQUAPORIN, que tiene por título Powering Water Reuse Biomimetic Arrow Membranes for a 20% Energy Boost. Jan es jefe de Ingeniería Comercial de Ósmosis Inversa en AQUAPORIN. Es ingeniero medioambiental con más de 16 años de experiencia, con práctica en los campos de tecnología de membranas, tratamiento de aguas y reutilización de aguas residuales. Jan es un apasionado de las soluciones innovadoras y sostenibles para el tratamiento de agua y la reutilización de aguas residuales y ha diseñado, operado y resuelto problemas de sistemas a todas las escalas, desde demostraciones en laboratorio hasta escala real. Como responsable de la parte de Ingeniería Comercial de Ósmosis Inversa de AQUAPORIN, Jan y su equipo dirigen el desarrollo de productos de Ósmosis Inversa biomiméticos exclusivos de AQUAPORIN y proporcionan asistencia técnica a sus socios y clientes. Muchísimas gracias, Jan, por estar aquí.
Thank you very
Es tu
much.
tiempo. Thank you.
And I apologize for not speaking Spanish. I've tried, but as a German living in Denmark, I'm still very, very busy trying to learn Danish. So please, if you have any questions afterwards, just reach out. Today, I'm very pleased to have the opportunity to represent AQUAPORIN and to tell you about who we are, what we offer, what we do, and what we have achieved in the field of wastewater reuse together with PUB, the Public Utility Board in Singapore. I'd like to keep it short on who we are, because you also have a leaflet in the welcome bag that tells you about the company and AQUAPORIN. We are based in Lyngby, just outside of Copenhagen in Denmark, and we have our operations across the globe. We have an office in Singapore with a heavy R&D team, and we also have operations in China, Turkey, and the US. Everything we do is centered around a core technology, technology that derives from biotechnology that we try and combine with engineered solution. So that's what we call biomimicry. So we combine biology and engineering to try and mimic what nature is doing to, in our case, purify water. So we have one core technology incorporated into all of our products, is well protected through a large family of patents. And we are active in mainly 3 areas: drinking water, food and beverage, and industrial water. Our technology, the core technology, is based on a Nobel Prize in chemistry that Peter AEDYR, the person on the very left, was awarded the Nobel Prize. And he discovered in the 90s that water purification in nature, so in all living cells, it cannot be just diffusion of water through the cell membrane. It has to be something that makes it more efficient. So he discovered the AQUAPORIN protein, a protein structure that all of us and all plants, everything in nature contains, that very efficiently transports water and water only. So the next gentleman here, Peter Holme, in 2005, founded AQUAPORIN, our company, and he wanted to utilize that potential from nature in engineered systems. And that's when he founded AQUAPORIN as the company in Denmark. This slide talks about how the technology works. I have already mentioned what you see on the left. This is how a biological or natural cell will work. It's a cell membrane, and inside this membrane we have many different proteins. One of them are aquaporins, and they transport water. That's all they do, and that's all they can do. So they can only transport water, nothing else. And then we engineer a artificial cell. That's the spherical shape here on the right, and we incorporate the aquaporin proteins. And then we incorporate that into a conventional reverse osmosis membrane. So we have that biological component. And then, of course, as any RO manufacturer, we still have the chemistry and the physics to work with. So that's our toolbox to make reverse osmosis or forward osmosis membranes. We have developed a wide portfolio of drinking water membranes, but today I'm focusing on brackish water. So we have a portfolio of currently 6 different types of brackish water membranes available in all industry standard sizes, ranging from very low energy consumption and lower rejection demand to high rejection. That will be our classic HR for very challenging and stringent permeate quality. We have done a lot of in-house testing, of course, to benchmark our products against what is available in the industry. So just one graph here showing you the rejection, the salt rejection over the required feed pressure. In this case, it was done on 40 or 4-inch membrane elements. And we wanted to see what is the pressure required to generate 2,000 gallons per day. And what you can see is that the blue points, that's our product portfolio. It trends to be on the left side of the graph. So you can achieve whatever rejection is required for your application at lower operating pressure. That is the whole value proposition of our AQUAPORIN Insight technology. That's in-house, but I'd much rather talk about what we do outside in the field together with partners. We have teamed up with the Public Utility Board in Singapore for many, many years. And one of their green goals is to reduce the energy consumption for their various water reuse activities. And their target is minimum 20%. So they do operate a lot of reuse facilities. And one of the cases where we started to collaborate was on a wastewater reuse or recycling location where they treated MBR effluent, so ultra-filtered municipal wastewater, using RO membrane to polish that to make it, quality for potable reuse. However, they do use it in industrial settings today. They don't use it for potable applications. So what we have done is we've installed a pilot where we have a 2-stage system using 4-inch membranes, and we have benchmarked our, in this case, Clear Plus 4-inch membrane against a membrane from CSM and a membrane from our competitor FilmTech, who has also presented just before us, because that was a requirement by PUB. The CSM is a very foulant-resistant membrane that they have experience with. The XLE is something that they also consider using. So what we can demonstrate with our membrane is that the feed pressure required, that is the blue graph, that's our membrane, is significantly reduced, achieving the same product or the same capacity, and also achieving a water permeate quality that is sufficient and applicable for that application. So we can demonstrate that we can reduce the feed pressure. We can also maintain the pressure drop across the element vessel array low. And we can, on the right graph, we can also show, again in blue, that this is a 3-month operation. Our permeates, our feed pressure remains very stable and does not increase, which would indicate fouling. So we have a list of all the water quality parameters that we monitor and meet. I think you will receive the presentation, so I'm not going to spend a lot of detail on this, but this is what we are allowed to share also by PUB. We cannot disclose all the details, unfortunately, but this gives you a good idea of what is important and what we're aiming for. So then this was 3 months. Then we wanted to, or PUB requested us to demonstrate that this works long-term. So we have installed another pilot at a similar location treating wastewater, and we have operated it for, by now, over a year. Again, showing that our feed pressure required is very stable. So the interruption in the graph represent clean in places. We have done, again, the details I'm not allowed to disclose, but I can tell that we have done very intensive clean in place to validate towards PUB that this is actually working. So one of the last CIPs that was done here was a repeated, I think, 1 week clean in place back and forth. So we can maintain the operating pressure over a year, and here in black, the feed conductivity, and in blue, the permeate conductivity, which is also just to show and demonstrate that this is very stable operation. All this has led PUB to install our membranes in one of their large-scale actual plants, production plants. There was 504 pieces of 8-inch membrane. This has been running since May 2024. And again, they have chosen one of their membranes, preferred membranes that they normally use. And they have installed a second train, again with 504 pieces using our membrane. And what I can disclose is that they already confirmed they're seeing significant energy reduction, about 22% over these 4 months of operation by now. The pressure drop is also maintained at a low level, again indicating no intensive fouling or any other operational challenges. And the water quality, again, is meeting the requirements. So we've done a little exercise in the context of this conference as well. What does this mean in operational cost saving and also environmental, well, reduced environmental impact? And of course, reduced operating pressure limits or reduces the energy consumption. If you quantify that in monetary terms, we conclude that over an operation of 10 years, you can save about $88 per element. So you multiply that by 504 and you get to the figures shown here in the graph. And obviously, as you reduce your energy consumption and feed pressure, you can reduce your CO2 and greenhouse emissions. Now, this was one of our cases that we have achieved in the wastewater reuse field. We have many more cases also, especially in the municipal water treatment, so well water treatment, surface water treatment. We offer a wide range of brackish water portfolio membranes. We are working on seawater membrane, so that is something that will probably launch beginning latest Q2 next year. We have everything that's required in the industry, standard warranties and terms. We have a projection tool, our own, that is accessible by the links. I think I'll send maybe a new slide deck because this is a little everywhere. And we are here. Søren, my colleague, commercial director, is sitting in the audience. If you have any questions, if you'd like to talk to us, we're here today, and of course available by mail and phone. I'd like to thank you. I'd like to thank the co-authors and I have to thank the PUB.
Yeah.
Singapore.
Thank you very much. Sure. I don't know if in the audience there is any question for Ian. Borja.
We're using, and that's what we focused on with this technology. Of course, we're continuously developing and looking into other options, but this option of incorporating the AQUAPORIN protein into the conventional polyamide of a membrane protects it in a way that, yeah, the final membrane is a polyamide membrane. So you can use it and you can clean it and you can operate it just like any other polyamide membrane. So in these cases, we've used a standard alkaline acidic cleaning in the normal pH ranges. So all that, I think, can be seen in the brochure or in the data sheets that we have available, that the cleaning ranges are wide enough for you to just operate them normally.
One question, Jan. We have seen a pilot in a container for that plant. That plant in, I mean, do you have pilots available in containers? Just, I mean, if anyone here is thinking of testing your membranes in a pilot, do you have available your own pilots, or it's something that is done case by case?
We don't have a parking lot full of pilots available, but we are very much collaborating with everyone who's interested in finding solutions. Yeah, we do have some pilots ourselves, but of course we always try to have them in operation, and currently that's the case, but they terminate at some point. So yes, okay. Definitely happy to collaborate on piloting.
One last question that, well, checking in your website and talking about the connection between water and power, I saw that you have experience with pressure retarded osmosis in trying to get the energy from the brine of the seawater treatment plants. Is possible? How's your experience? In which states of art is that? I don't know how to explain. I think that everybody is expecting for that, but probably it's not already the moment. But we would like to know your.
Yeah. So we are very active in forward osmosis in the food sector. It's a very similar technology compared to, let's say, pressure retarded osmosis, or the membranes are. We are not as such active in pressure retarded osmosis at this point. But maybe we can just catch up after in the break and discuss also what you were referring to. Yeah.
Okay. Many thanks. So if there is no more question, we will go for the next session. All right. Thank you very much.